Very good morning to everyone. In the last presentation, we were dealing with the frontier molecular orbital theory. In this frontier molecular orbital theory, we have dealt with the fact that it is the atomic orbitals of 2p which are involved in the reaction are responsible for the pericyclic reactions. It is the interaction of highest occupied molecular orbital HOMO with the LUMO which is responsible for the reaction that occurs in the pericyclic reactions. We have seen about the molecular orbitals of pi electrons of alkene and butadiene. Today's subject of discussion is how to write the atomic orbitals of the pi electrons of 246 octatriene. As it has 4n plus 2 pi electrons, 6 pi electrons, it has the orbitals arrangement which whose interaction can give rise to bonding orbitals and anti-bonding orbitals. When it has 6 pi electrons, 3 bonding orbitals and 3 anti-bonding orbitals are possible. Let us look into how to represent these atomic orbitals of 246 octatriene. Here if I take 1, 2, 3, 4, 5, 6, 7, 8. At 2, 4 and 6 position, it has double bonds. And the double bonds, the pi bonds has pi orbital or 2p orbital which are perpendicular to the plane of the system. And these 2p orbitals we are representing over here. The 2p orbitals between 2 and 3, 4 and 5 and 5 and 6. The 2p orbitals are represented. In the bonding orbitals are found by linear combination of these atomic orbitals. In the first stage, all the 6 2p orbitals are in the same phase. It is something like 6 friends which I represented here are going in the similar direction with similar type of mindset. The next, as they are in the same mindset, same frequency of thinking, they are having lower energy and this is represented as psi 1. When it is at the next higher energy level, the 3p orbitals are in one phase for 2, 4, 2, 3 and 4 and 4, 5 and 6 orbitals are in the opposite phase as that of the first one. There are 6 friends and there are 2 subgroups in the same group. Though they are together, but they have some difference of opinion. That's why they are divided into 2 subgroups which are having difference in opinion. This is represented as psi 2. The next higher energy level, the 2 and 3 p orbitals are in one phase. 4 and 5 orbitals are in the opposite phase of the first two. 5 and 6 or 6 and 7 p orbitals are in the opposite phase of the 4 and 5. This is 6 friends in as 3 subgroups. First two groups in one phase, second two are in opposite phase, and the third group is opposite to that of the second one. This is represented as psi 3. And now the highest occupied molecular orbital is psi 3. Anti-bonding orbitals are possible. Here 2 and 3 p orbitals are in opposite phases to each other. 4 and 5 atomic orbitals are again in opposite phases. 6 and 7 atomic orbitals are in opposite phase. I see here like this. The 6 friends divided into 4 groups. The first one and the last one are opposite to each other. The second and third are in one phase and it is opposite to the first p orbital. The 5 and 6 are in one phase. They are in the similar phase, which is opposite to the 3 and 4. This is represented as psi 4. It has 4 subgroups, 1, 2, 3, 4. These two are together. That's why one bond is possible. These two are together. That's why there is one bond is possible by one molecular orbital is possible by the interaction of these two p atomic orbitals. Here this is one bond, this is another bond. Two bonds are possible. This will be the lowest unoccupied molecular orbital. The next is psi 5. Here the 2 and 3 2p orbitals are in opposite phase. The 6 and 7 atomic orbitals are in opposite phase. And 4 and 5 atomic orbitals are in the same phase. It is something like a group of friends of 6 in which they have 4 divisions, 1, 2, 3 and 4. The first, second, fifth and sixth are on different phases and only the third and fourth are in the same phase. Psi 6, all the 2p orbitals are opposite to each other. There is no bonding formation between the two p orbital combination because they are in the opposite phases of each other. As per frontier molecular orbital theory, it is the outer shell of electrons of atoms which are very significant to determine the chemistry of atoms. The highest occupied molecular orbital is the key orbital which determines the reactivity of the particular starting material or the molecule. These are termed as frontier orbitals based on the two theories. This is the effect of interaction between frontier molecular orbitals. The frontier molecular orbitals may be HOMO, LUMO or SOMO. If two highest occupied molecular orbitals come together, both are having electrons, then they repel each other. That's why there is no possibility of bonding. The reason behind this is that both the HOMO of two different compounds are having electrons in it. That is, both the bonding and anti-bonding molecular orbitals are filled with electrons, and that's why they repel each other, and that's why no bonding can occur. If there is interaction between the HOMO and LUMO, HOMO is having electrons filled, LUMO is having electrons deficiency. That's why the interaction with HOMO and LUMO can give rise to a bonding situation. HOMO is something like an electron donor, LUMO is something like an electron acceptor. That's why bonding is possible. The LUMO and LUMO both are electron deficient. That's why no interaction is possible. Singly occupied molecular orbital and highest occupied molecular orbital interaction can give rise to bonding situation because HOMO is electron rich, SOMO is electron deficient. It is half filled. As per Woodward-Hoffman's rules, it predicts whether the pericyclic reactions is possible or not under the given set of reaction conditions. We can predict in this fashion. It has predicted in this fashion. It has the number of electrons, pi electrons is 4n electrons. N represent as an integer. 4 into 1, that is, if it is having 1 is an integer, 4 into 1, it is having 4 pi electrons in the molecule. It can be induced thermally. When it is induced thermally, it undergo Kohn rotation to give rise to bonding situation. The two p orbitals, they combine together, they undergo rotation, which we call it as Kohn rotation, to give the bonding situation. If it is induced photochemically, then it undergoes disrotation to give rise to bonding situation. If it has 4n plus 2 pi electrons, the thermal induction of the reaction gives rise to disrotation to give the bonding situation. If it is induced photochemically, a molecule with 4n plus 2 pi electrons, it is the Kohn rotation which gives rise to this bonding situation. What is this dis and Kohn rotation? The Kohn rotation, both the orbitals rotates in the same direction, either clockwise and anti-clockwise, to give the bonding situation. In this rotation, both the orbitals rotates in opposite direction. One orbital rotates clockwise, another orbital rotates anti-clockwise to give the bonding situation. This is the prediction of the Woodward-Hoffman rules. In the next presentation, we will discuss about this application of Woodward-Hoffman rules to predict the reaction, whether it can be induced thermally or photochemically, whether what type of product is formed, and the stereochemistry of the product which is formed. Till then, have a nice day. Thank you.